discussed this plastic pipe here. We're going to just discuss again something that we talked about before when it comes to jointing this particular type of pipe, okay? You'll all be familiar with, you should be familiar with this stuff here, okay? What's it commonly known as? Glue, okay? But as you remember from what we discussed before, that's not the correct name for it, is it? What's the correct name? Solvent cement, that's correct guys, okay? It's solvent cement, and the process that we went through when we used solvent cement previously and we were jointing a fitting to a piece of pipe, what was that process called? Solvent weld. That's solvent welding, that's right, okay? And guys, when we're talking about solvent welding, it's a, as we talked about it before, it's a weld. So how does that joint create a seal? A chemical reaction, that's right, and that's why it's called a weld. So the plastic, pieces of plastic are heating up and joining together and forming a bond which creates one big lump of plastic, isn't it? You can all remember that from what we discussed before. Is there anybody here that can't remember that or doesn't understand that principle? Good, good, okay? So, we're going to go over how we did a solvent weld joint again, guys, okay? This stuff here is commonly known as a degreaser, okay? You all remember that, yeah? Okay, a degreasing agent. And we use the degreaser by putting some of the degreaser on the pipe like that, okay? And when I do that, guys, what is it that I'm doing? What is the degreaser doing in that case there? It's basically just a cleaner, isn't it? It's a cleaner to take any foreign grit or matter off that surface and create a bonding surface so that the catalyst agent that we're going to use will actually melt the plastic. Okay? So we'll take solvent weld material here. Okay? Okay guys, I've put some solvent weld material on that piece of plastic there. Is there a problem with what I've just done there? What do you think it is? That's true, because what will happen is a whole lot of foreign matter will get into the joint and the joint won't be clean. Yeah, basically you're right. You picked up on the fact that in actual fact I haven't put enough on there, have I? Okay? So that's one of the problems that we've got when we're looking to do a solvent weld joint, is the fact that we need to make sure that we've got adequate amount of solvent on there, okay? So we need to put adequate amount of solvent on there. When we put that solvent on there, guys, what's the other thing that we should consider when we're putting the amount of solvent on? If we have to consider that there's an adequate amount on there, what is another problem that we could have? If we have excessive amounts of solvent on there, right? Okay, everybody aware of that? One of the things that we want to avoid when we're solvent welding is not having too much solvent cement on the joint and making a messy joint. Okay? Solvent both sides. Like that. Put that on there like that. Okay? Give it a little twist if you remember. A little twist like that. Okay? So what are the two things that we should look for when we've done a solvent weld joint there? That's right. And if there is a certain amount of stuff running down the side, that's a good indication of too much, okay? And what's the other side of that coin that we're looking at, that we consider? That's right. So what we're looking for, if you remember guys, we discussed the fact that we're looking for a bead of solvent cement just sitting on the surface there, because if that bead isn't there, we aren't too sure if there's enough solvent cement in there. We can't guarantee that that solvent cemented joint has actually sealed. We can't see that bead. That's what we were looking for, wasn't it? To see if that bead was there and then we know that there's enough solvent cement in that joint to seal it. Okay. Now, what's the pros and cons of using this particular type of joint here? If I was to say to you, what's the most important benefit of using that particular joint here? It's quick. It is quick. Very easy to do, isn't it? You just push it on, put the stuff on, push it on. That's a good point. It's cheap. Yep. The fittings, these fittings in comparison to some of the other fittings that we use are quite cheap. That's true. Okay. But can you remember, guys, what we talked about? The fact that this piece of plastic here is now, once that goes off, it's now one piece of plastic. Okay? Yeah. So it's very, very strong joint, isn't it? That's right, okay? And we talked about that. It's a very, very strong joint, guys. Okay? The negative side of that is the fact that once we put that on there, what can we do with it? It can't come off, eh? So if we were in a situation whereby that joint there you needed to do some maintenance or something like that to the pipe that you're using to connect that joint, then all you can do is cut it. Hey, you can't fix it. You can't dismantle it or anything like that. So that's a negative aspect of this particular type of joint. Okay, and it's something that you should consider when you're doing that, when you're deciding which particular type of joint is what to do. Okay. So that's a solvent weld joint for us, right? Cut.
Right.
Okay. So Alan, we're just going to have a look at assessing this piece of work that you've done here. Okay. So this particular piece of pipe here, what is the gradient on this? Yeah. 25 millimeters.
25 multiplied so by the meter.
Yeah. Okay. So 25 millimeters over a meter is the correct gradient for that piece of pipe. Okay. You've got nice fixings on your stack here. Okay, if I feel inside here, I can feel that this piece of pipe work here isn't protruding into the stack, so that's the correct distance inside the fixture there. Okay. When you were doing your solvent welded joints here, what was the main health and safety consideration that you took into consideration? Yeah. For health and safety.
Health and safety, for the solvents, when I'm doing the solvents and stuff, I never got the stuff from that in my hands. I'd used a rag.
Wipe up any excess. And as far as the area that you're in,
I thought PPE.
Yeah, and adequate ventilation.
Ventilation,
that's
yeah,
right. Okay, so you had adequate ventilation when you used the solvent cement. Okay. Now, if I measure that there, from there to there, that's 500 millimeters. That's correct for your drawing there.
Right.
Okay. Measure this here, 500 millimeters from the invert of the trap to the centre of the junction there. Okay. So if I measure this here, you've got 300 millimeters to the top of that point there. So that is a correct measurement as well. Okay. You space these clips off the wall there to keep that piece of pipe there straight and true. Okay. And you've got good alignment with the squareness of this piece of pipe here with that piece of pipe there. Okay. So that's looking all very well. Good piece of work.
Right, thanks.
Okay. Cheers. So, Stephen, we're just going to assess this piece of work that you've done here, okay? Just check the measurement. You've got a measurement here of 500 millimeters, and what did it say on the drawing that you did? This one here is 500 from the invert of the trap to the centre of the junction there. Okay, so that's correct. Yeah. Okay. This one here is 300 millimeters from that position there to the top of this trap here, which is the correct measurement there. Alright. Yeah. I'll just check in here to see if this piece of pipe's been pushed in the right distance. That's good. Okay. Now, as far as the gradient of this piece of pipe is concerned, how much is the gradient? What did you make the gradient?
25 mil above what is set.
Which is 1 meter wide. So it's 25 millimetres over a metre.
Yeah.
Okay. Very good. Now, is there anything about this installation here that you don't understand or you wanted to ask me any questions about?
No.
Okay, you're quite happy with that? I'm happy with that installation here. That's a pass. Okay?
Yeah.